Hi everyone, thanks for joining this afternoon. So I'm Jess, the policy lead for the IUCN Peatland Programme. David Large from Nottingham University will be chairing the session, but I'm going to kick off with a little bit about why we might want to talk about tracks and then some findings from my research that was more based on temporary tracks. So why would we want to discuss linear developments? So there was a paper by Ben Clutterbuck at Nottingham Trent that sort of highlighted in 2020 that in some areas the density in the UK is greater than that of the main UK road network. That's not just surface tracks, that's unsurfaced tracks as well. They're classed on most SSSIs, SACs and ASSIs as operations likely to cause damage and thus requiring consents, but they can form quite significant networks in some of these areas. Has that got a...
Sorry, Jess, that's me. I can't deal with the Teams chat at the same time. Is that like...
Okay. So if I just sort of highlight this image here, this is an area in the North Pennines, and you've got a few different things going on here. So this was, it's from an estate, as you can see from the grouse spots, but you've got an area of track that was removed 7 years prior to this photo being taken, a new mesh track that went in about 6 years before the photo was taken, and then you can see all the ad hoc tracks that are quad bike tracks kind of springing off there. So, I'm supposed to, yeah, okay. So gives you an idea of why we would kind of, if these sort of networks that form in areas of these tracks. The clicker's gone again.
Oh, sorry.
But there are still many areas that we're lacking sufficient data, and it hampers the decision-making process around what is necessary for regulators. So that's what we're kind of here to sort of talk about today. So from my work, I looked at temporary mesh tracks. So I'm just going to run you kind of briefly through some of the ecological impacts that we found. Significant lasted impacts on vegetation assemblage, post-abandonment or removal. They're quite long-lasted and persistent in the environment. Quite significant changes in the type of vegetation that you find along these sort of structures. Microtopographic structures are obviously quite flattened. If you're talking about surface tracks, heavily aggregate surface tracks, they're completely removed obviously, but on temporary mesh tracks it's kind of flattened out and simplified, dominated by cotton grasses in comparison to reference areas. Significantly reduced sward height as well. We found that was quite graduated out from the edges of mesh tracks. And then a range of physical impacts as well. You can see in some of the photos here a lot of the rills that form down the side of some of them, standing water on the surface. We identified high levels of compaction across most track areas. David's going to talk to you more about that. Spatially altered soil moisture patterns on tracks occur as well, whether they're removed or abandoned in the case of these mesh tracks. Increased overland flow frequency and resultant sediment loss. When we removed the track, my work was based at Moorhouse in the North Pennines. Lots of sediment runoff from all the kind of bare areas that were left. Trajectory for recovery after removing a track is a very slow process, and the changes to vegetation are long lasted. Even post-removal, as the vegetation started to regrow on the track, we found that it actually started to diverge once again from the controls. It seems to enter an altered state, and similar things have been found in North America. So one of the things as well that I want you to sort of think about in this session is whether it's possible to control access to these areas, and particularly if they're on protected sites. We might put a temporary track in, and it doesn't matter who intended to use it. As many of you will know from walking across a bog, a track or just even a simple trod is a kind of welcome reprieve from slogging over tussocks. So people will favour using it. So once you've put something in, I would argue that it might be permanent even when it's intended to be temporary. Compaction effects are long lasted, if not permanent. As I said, David's going to discuss that a bit further. And bare peat's very vulnerable to erosion processes. In terms of some pictures of that, so this is a track in the North Pennines, the one that I showed you in the aerial photo earlier. So you've got the track here, was the removed track. After 18 months, that was the newly input track. Then that was 3 years later, so some vegetation, but you can see a lot of water flow over that, a lot of erosion. 6 years later, and then this is Moorhouse, where I removed the track. That was one of the plots. 20 months post-removal, and that was 3.5 years post-removal. I just visited that in July this year, with one of my colleagues from Natural England, so it gives you an idea of how long these things take to recover. So what I'd like to leave you with when we're thinking about temporary tracks is that there's nothing more permanent than a temporary solution. And I'll hand over to David.
Thank you, Jess. I have the dubious honour of chairing this session I'm presenting, which wasn't the initial plan. I think it was a different chair plan to start with. And it's unusual because in theory the chair should be quite independent. But I will try to stimulate your thoughts. So that's my job, is to stimulate thinking. So the opening thing here, and you can just hit the return on that for me, please. I'll just stop that image from moving, it kind of makes me dizzy. I think, yeah. Oh, maybe I'll do it. No, I didn't want that. Right, there we are, I stopped. I started off with someone running on peat, or a peaty track, which is not just about vehicles, and we tend to think tracks are vehicles, but the impact of people's feet is equal to that of the impact of a vehicle, particularly a fairly heavy vehicle. So we need to think of tracks in the broadest possible sense. It could be animal tracks, it could be grazing density, it could be tracks that are permanently used by people, it could be tracks that are used by vehicles. And the vehicles rightly should be our focus because there's a lot of development on peat, but let's not lose sight of the other options. So what is the effect? Well, this is a diagram. It's two maps of a wind farm. It's the Strathy North wind farm up near the north coast of Scotland. And these are condition maps that we've generated for Nature Scot. I'm not going to go into all the background to this, I just want you to accept what is on that map and I'll explain to you what it shows. Black is areas that are subsiding, green are areas that are stiff, and blue are areas that are wet and dynamic because the surface is going up and down with changing water content. Between 2015 and 19, there's a large area of black on here. The tracks are shown as yellow lines, and if you follow that forward, you can see that the tracks nearly all stiffen in that area. So using remote sensing from space and looking at the motion of the ground, you can detect the impact of the tracks on the surrounding peat. By more detailed analysis of this, you can see that the tracks effectively compartmentalise the peat. They act as hydrological barriers to the flow of water between compartments. But that wasn't really how they were designed. They weren't designed as we design, say, ditch blocks, which are more carefully thought out and are much smaller compartmentalisation of the flow of water in peat. So these tracks are there designed as tracks, not really as barriers to fluid flow. And that can result in various engineering problems if you get imbalances across the tracks. Second line of evidence is what actually happens when we compact peat. So we've done a bit of modelling, which is over on the left-hand side here. A bit smaller screen, a bit larger really. So what we have here, what we've done is we have a very advanced model of peat. So we've grown a peat for 5,000 years, and then we've stuck a digger on the top for a year, because it works in yearly increments. And then we've looked at the effect of the weight of that digger on the peat, and we've done that through a model. And what you can see here is we've got the height above the base of the peat on this axis, and then we've got the density along here. This is the surface, if the surface position if it is not compacted, and this is the state of the peat under near natural conditions, in the blue line. If we put on a 70 kilogram person, which is equivalent to a 1.9 metre 14 tonne vehicle, 1.9 metre track 14 tonne vehicle, you get a very small amount of surface compaction. Noticeable, but there. If we put on a 1.2 metre tracked vehicle of similar weight, we get this massive amount of compaction. The surface density increases dramatically, the hydraulic conductivity crashes, it goes to really low values, 10 to the minus 10, the surface becomes impermeable, effectively. It's almost like a kind of a sort of pretend hard pan in a soil. You will get ponding in that surface, you will get rapid overland flow, and you can avoid that simply by going to a broader tracked, a wider tracked vehicle. Probably better for me.
No worries, thank you, just for the recording.
Okay, thank you. Is it on?
It is on, you
Okay,
want
that's all right. We can then compare that to data from the field. So this is from the Loch Nagar site. It was provided by Gillian Donaldson-Selby from the James Hutton Institute. And she measured density over really broad sections of peat. She had an uncompacted control, which is shown as the blue dots, and then an area that had been restored, shown with the orange squares. and you can see that predicted effect. And it's very much a surface effect, and the surface is the most important bit for the flow of water through peat. It's the most permeable bit. So if you lose that, you really have disrupted the hydrological function of the peat. We did grow it back again after that, which I've not shown because I don't have time. And you don't lose that compaction. It's irreversible compaction is what you have there. It remains permanently within the structure of the peat. And we can see the effects of that. These are some images from Ian McKee that shows that puddling and the gathering of water on the surface. And Jess showed photographs that show exactly the same thing as you would expect from water on an impermeable surface. So the final thing I'd like to think about is the stability of the peat. Because when we add vehicles to peat, we're adding load. And using a different version of this model in 2 dimensions, we have a stability diagram for peat. And we will show you evidence that this is not entirely without rhyme or reason. So on this diagram here, we have along the base, we have the slope angle going from 2 degrees to 8 degrees. And up the vertical axis there, we have the thickness of peat. And it's shaded into 3 regions. My former PhD student from Indonesia isn't particularly noted for his colour choices, but we have the colours that we have. And at the bottom here in green, we have the zone where peat is unquestionably stable. It's not going to slide off the hill. And any little movement, any of those little mass movements are the precursor to erosion. So that's what we're thinking about here, the precursor to erosion under natural conditions of growth. When we go into the yellow zone, this is where we start to exceed reported values of peat strength. There's lots of reported values of peat strength. It's a really hard thing to measure. So as we move up through that yellow zone, we're gradually exceeding more and more values of the reported mechanical strength of peat. Over to the left here, we're exceeding the tensile strength of peat. In other words, it's getting pulled apart. You conceptualise that as a bog burst. And the right-hand side here, we're exceeding the shear strength of peat. Therefore, we're expecting peat slides to be the predominant mechanism. And then when we get up into the red zone, we've exceeded all the reported values for the strength of peat that we could find in the literature. So this effectively tells you how vulnerable your peat will be to anomalous loads and where it should be in a natural landscape and whether it should be eroding or not. Now you might think it's modelling, therefore it's a pile of bollocks, and I wouldn't blame you for saying that. But if we then take data that was published on known peat failures and their type of failure, it matches really well to what we expect. So on the left here, in the blue squares, we have bog bursts, exactly where we would expect them, within the upper part of the yellow zone. And on the right, we have peat slides, shear failures. So I don't think this is nonsense. I think it's telling us about the fundamental structure and behaviour of peat. And I think when we put tracks on peat and we add load and we create imbalances, we should think carefully about what that might do to the peat and just how stable the peat might be. So, with that, we're not going to open up for questions now. We're going to flow seamlessly through all these talks, and then we'll have questions and a proper session at the end, if that's okay with everybody. So I'm going to pass on now to Andy Mills from Offshore Wind Consultancy. Is that right, Andy?
Yeah.
I'll let you introduce that.
Thank you very much.
Over to you.
Cheers, thank you.
Thank you very much.
This won't be an offshore presentation, so please don't worry about that. Right then, so challenges in minimising the impacts of track networks on peat and hydrology. So this is very much from trying to build a track in association with a wind farm in a sensitive environment. I've had some very useful chats with Scott McGarver from Pearl Frischman, who's one of the design engineers who works on these sorts of projects for a variety of developers. So just briefly, I'm a peatland geomorphologist and have been for 25 years. Co-authored the Scottish Government Landslide Hazard and Risk Assessment Guidance that's used on all wind farms. And lead author of the Nature Scott Research Report, which was so kindly referred to just now with those data sets, working on a lot of wind farms. The topics I'm going to cover are why do we need tracks and how do we approach track design? It's fairly obvious. For any of you who aren't familiar with how we look at tracks on wind farms and why they end up where they are. What are the constraints that we face when we're trying to do that? And where are the knowledge gaps or opportunities to improve track construction that might help reduce impacts? So why do we need tracks? Well, for lots of reasons: estate access, forest access, wind farm access, which is what I'm going to talk about, and other construction needs, so pumped hydro, for constructing grid, because we need pylons. And basically, we didn't have tracks, we wouldn't have any renewable energy because we wouldn't be able to access any of the locations we need to build turbines. So to meet the Scottish Government's 20 gigawatt target from the onshore wind sector deal, we need wind farms onshore as well as offshore. And unfortunately, as you can tell from the three maps there, wind energy is quite often focused in the uplands. So the map on the left is a heat map of wind energy from the Global Wind Atlas at 100 metres hub height. The central map is elevation from a 50-metre topographic map, and the right-hand map is the carbon and peatland map classes from Nature Scott's carbon and peatland map. And the pinks and the yellows are what are regarded as the most diverse and most valuable peatlands in Scotland. And you can see that the red on the left coincides with the brown at elevation in the middle, and the pink and yellow, which is the best peatland habitats, on the right. So this is where we have this climate crisis butting up against the biodiversity crisis. Ideally, we want to avoid peatlands. We would like to be able to put wind where there is no peat, but if we have to put wind at elevation, there almost certainly will be, or will be in rocky mountainous terrain. And because of that, there's been a lot of guidance. So we've had floating roads on peat, very useful, from Nature Scott and the Forestry Commission, about 4 different editions of the good practice during wind farm construction guidance, constructed tracks in the Scottish uplands, which came from Nature Scott, and more recent guidance looking at the effectiveness of construction mitigation, so how we make our tracks better. So there's a lot of guidance, and there's more than that. A common theme that comes out of all the guidance is that we should avoid peat, but it's in practice extremely difficult. So you might want to know how we decide where we put tracks, because you may have seen them on wind farms and go, why did they put it there? So I'm going to very, very briefly run through with you a typical design process for wind turbines. So here is an upland elevated part of Scotland. Those of you with keen eyes will see eroded ground on the sort of browner areas in the middle there. And this is OS Terrain 5 data, which means those gullies are quite large, or you wouldn't be able to see them. The blue dots are what you might typically see in a scoping layout submitted to say, we want to build a wind farm, it's going to be roughly this big. And that's the starting point, and that will be based almost entirely on wind yield and elevation. And those will be spaced because of ellipses which define the influence of turbulence from one turbine to another. So they can't get too close to one another, otherwise the wind farm won't operate properly. Now, pre-scoping, we collect peat depth data on a 100-metre grid initially, which is akin to what you collect for peatland action. And on this map, the purple hues are all peat, darker is deeper. The yellow is what is currently regarded as carbon-rich soil below 0.5 metre. We had an interesting debate about peat depth this morning. Once we've got the peat depth data, everything shuffles. We delete turbines in the really deep areas, and then we move everything else. What might not look like much to you, but we've moved things, maybe 0.5 metre or a metre's depth class into less impacting situations. And then we take that forward and we start to work with that. And we will go back and collect more peat depth data. But we will also have to look at other things. So watercourses and buffers, 50 metres on watercourses on blue line on OS maps. GWDTE, so groundwater dependent terrestrial ecosystems. Landscape visual, and a whole raft of other things that actually sit in a sort of GIS mash on top of the site that you're trying to develop. And then we'll start to link up all of the tracks. And the turbines aren't points, they're hard standings, which have large footprints. And the tracks aren't lines, they're widths with, depending on track construction methodology, shoulders, drains, and other things associated with them. And in amongst all of this, we also consider very detailed maps of national vegetation classification communities, so Mire habitats, M1 to M3 and M17 to M19, which are priority peatland habitats, and we try to avoid those. They're not shown on this map. Cultural heritage features, nesting areas, or aviation as well. So there's all sorts of things we have to consider. It's quite complicated. And then there's construction limitations. So we can't have more than a 400-metre radius change in gradient vertically, and we can't have more than less than a 50-metre bend radius looking down. So we've got limitations on the geometry of our tracks as well. So as you can see, crane transporting vehicles are very, very long, and they can only go around certain corners. So what type of tracks can we build once we have our tracks set up? Cut and fill tracks, where you remove all the material, level, and then build back up to the ground surface so that you don't waterlog. And then floating tracks on the right, and these are from the constructed tracks in Scottish Uplands guidance. And in simple terms, the direct impact is the red, and the indirect impact is the orange. And you can see on the floating track that the indirect impact the direct impact can be around half of the direct impact of cut and fill tracks, simply because you don't need to cut and fill on each side, and you don't need a drain because you're sitting above the ground. So floating tracks on the on the face of it, look like a better option. And that's how we try to design sites, use floating track where possible, and I'll come on to why this is a problem in a minute. Bearing in mind, I don't know what my times are, but I'm sure, can you give me the 5-minute nod when I get there? But yeah, so in most terms, cut and fill is worse than floating track. Cut and fill takes more habitat, it affects hydrology more because it completely slices through the peat and removes it. It displaces all the carbon. We need to work out where to put that peat with the carbon and keep it wet. And it's worse for stability, which I'll come on to. So floating, generally speaking, is lower impact than what we're going for. But this is where the problem comes. So thresholds for floating track construction. The key constraint really for floating track are slope gradient and peat depth. Floating track is not specified on slopes over 5%. 5% is 2.86 degrees, which is very little. And most of this relates to the surface of the track becoming sloping, which you don't want, but also to stability. And this is really limiting. So if we look at the site I showed you earlier, not a real site, but there enough. Here's our site. That's all the areas on that site that are 2.86 degrees or less, not very much. If we could push it to 5 degrees, which is about 8.7%, we'd still have more area where we could build floating track, but not a lot. And then if we compare that with all the peat on the site, vast areas of peat are not suitable for floating track construction, particularly if you compare this map with this map, and that's what we're working to at the moment. So that's extremely constraining, and we're unable to reduce impacts through the use of that construction methodology at the moment. Then the other issue is floating tracks compress peat, as has just been covered. Typically, it's only ever really been used on over 1 metre. We're pushing that threshold down, but there becomes a certain depth of peat beyond which you'll just squash it to nothing. And at the moment, I'd say about 0.5 metre of construction fill that forms the floating track would probably not be constructed on less than maybe 0.6 metres of peat. So, there are still large areas of between 0.5 and 1 metre which we're going to have to cut, and that can still be very valuable in terms of all ecosystem surfaces. So, what do we do? So, questions for industry, designers, everybody else. First of all, how much evidence is there for compression in these shallower peats? So that follows on from David's talk. What is the evidence for floating track performance on slopes greater than 5%? Someone's probably constructed them somewhere on over 5%. Are they still in the right place? Can we find out? And can we start to push that boundary so that we can use these tracks more often? And then what is the geomechanical basis for 5%? So as in so many aspects of science sometimes, things become rules of thumb, become law, become fact. And geomechanically, peat is extremely difficult to model. David's already pointed out that measuring shear strength is very hard. Can we improve our modelling of peat to be able to come up with a better threshold that reduces our impacts? So thing 2, stability. So Channelwick. I've got, how many minutes I've got? Okay, right. So Channelwick on the left, Shetland also in the centre last week, Scaregord, cows in the bottom there for interest, and guidance to govern how that works. Peat's difficult to model because it's made of seeds and stems and other bits, and there's water held in the cells, which breaks out of the cells into the pores when it's compressed or deforms, and that's one of many reasons why it's hard to model. But interestingly, and this is the key point, most failures associated with wind farms are where spoil has been sidecast during track construction and put on the edge. They're not actually like the Channelwick failure I showed you on the previous slide. So we need to put much more attention into how we deal with sidecast material safely. So bearing in mind time, and more to the point, we really need to be quite open about lessons learned from these incidents. We need to have root cause analysis so that we can prevent these things happening again. And the PLHRA guidance is going to be revised back end of this year, and we'll be putting sidecasting into the guidance as something that needs to be considered. So lots of questions there, which will flash up on the recording if you want to review them after the talk. I think looking back at failures and why they've happened is the key thing we need to do. And then the last thing, drainage, which has also come up. That's a nice diffuse area there with a big slice through it above the Channelwick failure I showed you 3 slides back. So that was a cut-off drain. How do we stop water? How do we stop impounding water on the upslope side of track? And how do we effectively transfer water to the downslope side of track? There is guidance. There probably needs to be more guidance and more evidence to support which types of transfer of water work best and in what contexts, and which are most long-lasting, because what we don't want is our culverts and pipes that sit underneath the track being squashed and becoming sausages pointing into the air and not conveying water back through the bog. And I have some questions there for you on drainage. That's 15 minutes. It goes very quickly, doesn't it? Yeah. Very clear. How do we get water from above to below? So that's the key question there.
Thank you very much.
Thank you very much.
So, next up, we have Guaduneth from Waterlands Action.
Yeah.
Over to you, Gavin.
Just 2 seconds while I just get our team's people queued up for the next bit. Sorry.
Yeah, no problem.
Pause you for a second.
This is no accounting on my time.
I'm not taking your time yet.
Right. Sorry, not having a proper tech person. You're left with me.
Here we go.
There you go. Thank you.
Thank you very much for inviting me for talking today. My name is Guaduneth Chico, environmental scientist. I do geography and then have moved into the environmental science, and now I'm really the action site coordinator for Waterlands in Ireland, doing peatland restoration with national parks. But obviously I have background on research, and that's why I'm presenting today is how we quantify the extent of these actually tracks and wind turbines that they're speaking about, and do assessment on how big is the problem, because we find out that we know is some impact on this, but we didn't know how big is the problem. So, not working.
Try again.
Yeah, here we go. So the issue, I guess, highlighting the same that the previous speakers have highlighted already. So obviously we got a conflict between where blanket bogs are and where the wind farms are sold, because it's an interest on both sides. So the Habitat Directive obviously protects the blanket bogs, even in the UK, after Brexit as well, still is applied in terms of the protection and so on. But then it's a mismatch as well on that mapping. So I think this morning we're speaking about this as well, like how we know where blanket bogs are and the peat depth and so on. Well, when you actually look the recognized blanket bogs on the Habitat Directive, usually doesn't match which you can actually see on the field as well. So it's not only about why it's protected and where we're going to install the wind farms, it's what actually have been recognized and the mismatch on that maps, and we'll see some examples in a minute. Again, it's an increasing interest, obviously, on green energy and so on. So it's a push on that, especially in countries like Spain and in the UK as well, in terms of, promote these green energies and wind farm installations. But again, the topographical location of blanket bogs are also ideal for this green energy. So again, looking at the impacts, and this morning, I think, and now as well, have been a lot of talks about the impact on hydrology and so on, but also we also research already on impacts on vegetation. So in Spain, we have one blanket bog that actually has changed all the vegetation just because the impact of tracks and the access of that track is not only for the wind farms, but also for farmers to access to the site. So you change the land use of the site already, just not only because of wind farms, but also other activities that can be facilitated by that tracks as well, which also need to be considered. So the aims of the research then was, first aim was assess the extent of these problems, so to know how many tracks actually we have on peatlands, and especially in blanket bogs. And the other aspect I'm going to cover later on as well is what is the impact on ecosystem services in Ireland. So we have done a full assessment on ecosystem services and how these tracks and turbines is affecting the ecosystem services on blanket bogs. So in terms of the methodology, I'm not going to spend much on here, but very easily what we did is digitize all the wind turbines and tracks across all the blanket bogs protected across Europe. Again, GIS analyze, I'm not going to spend much time on that. But I think what is really important is we calculate not only the number of wind turbines that we have in each county and so on, but also the density of that. Because it's not the same where you have 1 hectare blanket bog that maybe is unique on the area and you have 3 wind turbines on there, where you have in Scotland, 200 hectares of blanket bog and maybe you have 10 turbines. So again, assessing that by density as well is really important to understand the impact. And in terms to assess the impact on ecosystem services, what we did is use raster data sets, basically, 50 by 50 meters, and look at the statistics on that. So look how much value you have on the ecosystem services in comparison with the areas where we have the tracks. So results, so again, I'm going to start with European scale and then I'm going to move into Ireland. So you can see the problem there, obviously mainly in Ireland. And in Spain, actually, obviously this map by region, so don't think that in Spain we had that many blanket bogs, actually only a few, but obviously we have mapped this by regions, European regions. But again, what you can see there straight away is like they concentrate mainly in North Spain, where we have a very unique blanket bog and have over 400 wind turbines just in one blanket bog, which is insane. And again, you will see later on that the main issue is just because the lack of protection on the area and the lack of knowledge about blanket bogs. As you can imagine, everybody thinks Spain, sun. I'm from Spain, and I didn't know there was blanket bogs there until I was standing on them. But also you can see the problem in Ireland and obviously in Scotland. But when we look at the density, then the thing slightly changes. And that changed because obviously the extent that you have of blanket bogs and what have been recognized as well. So even in Scotland, you have the highest proportion of blanket bogs across all the whole countries. Actually, the protection is not like that. So actually, it's more protected blanket bogs in other countries, which actually made the problem even greater in Ireland and still Spain, obviously, even if it is only the 9.2% of the blanket bogs, but you can see that also concentrates the majority of the problem. So in the Irish case, going into detail now, I'm going to be very careful here to don't, in terms of using the Republic of Ireland and Northern Ireland, because there's some sensibilities there. But again, when we look at the whole island of Ireland, you can see that the problem is mainly concentrated where more blanket bogs are, on the west coast. But again, when we look at the density, we can see it's a bigger concentration on the Northern Ireland and in the Midlands in Ireland. So again, 186 wind turbines and 92 kilometers of tracks on blanket bog. We're speaking about protected blanket bog all the time. So it's not any pit, it's just protected by the Habitat Directive. So that's very important to highlight. And again, 83 hectares of that blanket bog have been affected as well. So it's not only the tracks and the wind turbines, it's just the platform that actually Andy Mills was suggesting as well. You know, you need a platform for the wind farm. You need a space for the track to, for the trolley and the transport of the wind turbines into the bog. And certainly the extent on the Northern Ireland as well is likely to be underrepresentation because the lack of data or detailed data on blanket bogs in Northern Ireland. So again, we assess that based on what we have or the best data available. But when we assess with all the peatlands and looking at the topography, we actually find out there was a lot more wind turbines that have been actually reported. So again, the problem that we have reported is actually underestimation, so it's a lot more that actually we report on this research. And again, I think the same problem with the Republic of Ireland. We have a protection. I work for national parks and I have seen that map. But then we have all the research from Connolly and Holden, for example, from Trinity College in Dublin, that actually duplicates the extent of the blanket bogs, and actually have published something this year as well that duplicates again the extent of blanket bogs. And that's all based on that pit depth that we're calculating before. What is blanket bog? It's 30 centimeters, 40 centimeters. So it's very, very important to assess the problem as well. And again, that's the total wind turbines. When we look at this research for Connolly, we can see that they increased to 1,200 wind turbines and 732 kilometers of tracks on deep pit on blanket bog. So finally, I'm going to look at the ecosystem services. Again, this is the value of ecosystem services. So what we did here is look at the ecosystem services value at county level in Ireland, blanket bogs, and then on the wind farm. So basically, we start the information of each ecosystem services at these three levels and compare them to see whether the ecosystem services on wind farms infrastructures actually is higher or lower. So we did that for biodiversity, soil carbon, water storage, and water quality, because are the four that are more important for blanket bogs, if you like. And then when we look at the county level, obviously don't care about the numbers, but you can see very high numbers. But when we look at the blanket bogs, you can see that all the values are going higher. So for that four specific ecosystem services, we can see that on blanket bogs, the ecosystem services is even greater. Now, when we look on the specific areas where we have the tracks and we have the turbines, obviously for biodiversity, we can see actually, okay, that was not the most valuable part of the blanket bog. So you could say, okay, that's not too bad. But what we did as well is for the other three, and what we can see as well there is like the other three ecosystem services, we can see that the value of the ecosystem services on that specific area where we have the turbines and the tracks is actually the best place of the blanket bog. Therefore, it's a question there about should we try to start to think about this as well as other things like hydrology, pit depth, and so on. So in conclusion, I guess what we need to highlight is that it's a large extent of these infrastructures already on blanket bogs, and it's not fully understand what the consequences are of that. We have some tips today, which is really good to see as well, some more research on this. But again, it's nothing a long term. Another problem is the lack of recognition. So you can see when you compare maps, even in Scotland, in Ireland, in Spain, the real protection in comparison with what is actually blanket bog is completely different. So we really need to update inventories and make sure we tell the governments to update that and provide how we classify them, which is very important, because if we don't know how we classify peatlands and what peatland is, then the government will not do the job either. And again, I think the underestimation of the issue and the lack of research as well is very important, especially long-term research, because we know a lot about short-term but not long-term. So I think doing more long-term research will help us to understand all of these subsidence or the water, the drainage, what is the impact on the long-term on water tables and so on. And again, looking at the island, again, just highlighting that important point that the wind farms have been installed in the higher value for the ecosystem services. So again, if you want to read about the research, it's published on scientific reports, and then, the second paper about that ecosystem services is now on prep, so hopefully we'll submit that soon. But obviously I'm restoring peatlands at the same time and doing research, so it's quite complicated, but thank you very much.
Okay, cheers Emma, thanks very much. Well, good afternoon everyone. My name is Mike Shewring. I'm sorry I can't be there with you this week in Aviemore. Unfortunately my daughter broke her arm earlier this week, so it's been a bit busy. But anyway, what do I do and why am I talking to you today? So I work part-time as a conservation scientist at the RSPB, mostly working on upland issues. I'm going to be talking about some research I'm doing at the minute on mapping upland tracks across the UK. So this work is ongoing. I'm mostly talking about why we're doing it, plus a look at how and some initial results today. So first of all, why at the RSPB are we interested in upland tracks? Essentially, there's good evidence that surface and unsurfaced vehicle tracks can have significant environmental impacts, including things like soil disturbance, compaction, peat subsidence, increased surface runoff, and these can lead to further impacts at wider geographic spatial scales on downstream flow regimes, water quality, aquatic habitats and hydrological connectivity in wetlands and bogs. And tracks have also been linked to the spread of invasive species, effects on soil microfauna, loss of changes in vegetation cover, and also increased movement of mesopredators through a landscape. They can also have long-term effects on vegetation cover long after they've been removed in sensitive habitats, so things like blanket bog. So in short, more tracks in the uplands often means a greater degree of habitat degradation, and hence robust data on the extent and locations of track in the UK uplands is really of great interest to us as we advocate for future richer nature, essentially. And there's a really good review paper on some of the hydrological effects done by Ted. But why tracks on peat in particular as well are of concern is, tracks on peat specifically alter its structural integrity. Building on peat compresses the peat and alters the drainage patterns on and around the peat, both within the peat body and over its surface. And the level of compression and disruption depends on the structural wetness of the peat in question, but often alters the hydrological system of the blanket peat, either the surface or the subsurface level. And this is often the associated trackside drainage, results in the settlement of peat, disrupts the hydrology both within the subsurface peat body and over its surface, and can lead to subsidence and collapse of areas and cascading changes to vegetation and bog health. And things like upslope pooling and downslope drying when tracks are located on blanket bog. We can see an example of this here in some dip well data from a Welsh wind farm site with box plotted dip well data on the left above the track and below the track on the right, showing pooling and drying effectively. So that's kind of why we're interested in tracks. But what do we already know about the locations of tracks in the UK, in the uplands? So there's no real definitive data, but there is some good evidence from this paper by Ben Clutterbuck and et al. And they manually map tracks in a sample of the UK uplands, run about 1,900 kilometres squared, and identified around about 2,000 kilometres of track, giving an average track density of around about 1.1 kilometre of track per kilometre squared. And in blanket peat, they estimated a total track length of 6,820 kilometres of track, based on a 301 kilometre square sample of blanket peat. They also noted that track density was strongly correlated with areas of managed heather, and noted land use as really being the best predictor of track density in the uplands. But this is based on a relatively small sample of the UK uplands, and is not really comprehensive, its coverage. I mean, there's still quite a bit of uncertainty around these lengths of track in the uplands, and the effects they're having on habitat quality in the uplands. So what have we been doing? Well, our first kind of step was to look for other data sources, to see if there was any existing data sets out there that we could look at, might give us an idea of what extent of track we've got in the uplands. So we started using OpenStreetMap data. OpenStreetMap is a project that creates and distributes free geographic data for all over the world. The data is crowdsourced and added by volunteers. They collect data from surveys, or maybe trace from aerial imagery or satellite imagery, and also import any other freely available geodata. This means that the data quality can vary really significantly between locations, and the database is not comprehensive, but it's a good place to start. So using the Overpass API and the interface via R&R Studio, we downloaded all OpenStreetMap track data from the online database. We then intersected this, cookie cut it, to obtain only those tracks located in upland areas of the UK, and based this on the countryside survey defined upland areas. So that's the area shown in the map in the centre of the screen. And this gave us approximately 52,000 kilometres of track in a search area of around about 58,000 kilometres squared. So really not that far off the Clutterbuck paper average of around about 1 kilometre of track per kilometre squared. But as I said earlier on, we're also interested in how much of this was over blanket bog or deep peat, peaty soils. So we also intersected this with deep peat layers using country-specific relevant data sets on peat depth. And this identified 4,247 kilometres track on deep peat. Essentially around about 8% of the OpenStreetMap upland tracks were over deep peat. And where are these tracks located? Well, the UK and upland areas of the UK. This may be a slight indication that higher concentrations associated with plantation coniferous forests, but this scale is really hard to say. So we're really still keen to try and improve on the estimate and get a more robust estimate of total and upland track extent, and hence started exploring other options as well. Namely using deep learning, or AI, to automate the mapping of tracks in aerial imagery. And to do this, we used the map track data set collected by Ben Clutterbuck and his colleagues, which they very kindly provided to us. And first of all, we manually verified the geometry of each track. So lining it up with the center line of the tracks where it didn't directly align, using get mapping 25 centimeter pixel RGB aerial imagery. And this realigned the track segments to make sure we had accurate segmentation training maps. Following this, we created a training data set for our segmentation model development by downloading all the images as kilometre square image files that overlap with any of the map tracks from this data set. These kilometre squares are then chipped into smaller images and masked with the track shape files to produce segmentation maps. And this is the image you can see on the right of the screen there. It's essentially a picture with zeros where there's no features of interest and ones where your feature of interest is. So this track in this instance. This data set was then used to train a fully convolutional neural network with a UNet architecture. This uses a process called backpropagation, or basically learning by error, to locate the features of interest in an image based on the supplied picture, and the segmentation master shows the feature that we're really interested in detecting. So our data set consisted of 6,000 images in total, and this was split into a training and test data set, where the model was trained on around about 5,500 images and evaluated against a held out subset of 600 images, or a number of epochs. So this is just a visual representation of what a UNet model looks like, illustrating how the images are turned into feature maps at different spatial scales, so different sizes, from smaller and smaller sets of pixels, while still retaining the spatial information about where those actual parts of the image come from. But how did the model perform? So you can just see some average scores there from our model runs, and this average dice score is essentially saying that the overlap between the segmentation masks from the prediction and our training data was around about 84%, so pretty well. And what do the outputs look like? So this is some of the outputs from our predictions. The aerial image on the left shows the image passed to the model, and then we've got our truth, or the segmentation mask that we manually drew from our track lines in the centre. And then on the right-hand side, we've got the model prediction. So you can see that the model's performing pretty well, maybe missing an area here in this image. And also in these images as well. It's picked up a track that we haven't actually picked up through mapping here. This might be just an unsurfaced track or something like that. But overall, you know, the model is performing pretty well in tracks. So what really are our next steps? So the next steps for us really are to scale this up to an independent test area. And this is something that's actively ongoing at the moment. And I completed this yesterday. And we're going to evaluate, just recently evaluated the performance of this on a spatially random set of squares. And this performs still at a high level, so around about 8.4% balanced accuracy. And then really our next steps now are to scale and predict the entire GB upland area, so that 58,000 kilometre squares, and then extract those tracks that we identify as line strings and create an upland track network for the UK. That'll allow us then to analyse the distribution of this and investigate the environmental and land management correlates of track density and occurrence, and perhaps explore some of the impacts of that. And that's where I am. So yeah, thank you very much for listening to that. Hope some interest.
Wonderful, thank you ever so much.
Thanks, Mike. I see we have Arwel here.
We do, yeah.
Can you hear us?
Can you hear us okay? Yeah, if you could share your screen like Mike.
So we have Arwel Williams and the Welsh Government will be talking to us next.
Give me a shout if you can see that at your end, guys.
Loaded and yeah, you're good to go. Thank you.
Brilliant. Thank you very much, Emma. Afternoon, everybody. I do hope you're all enjoying the conference, and I'm very jealous that I can't be there with you in person today. I'll just introduce myself briefly. I'm Arwel Williams. I work for the Welsh Government in the Soils, Peatland and Agricultural Land Use Planning team. So today I'm going to look at linear developments on peatlands from a planning policy perspective here in Wales. Just to give you a brief sort of introduction and background to the team, in the Soil, Peatlands, Agricultural Land Use Planning team, we've sort of got three main work areas. Firstly, we've got a long-standing responsibility on protection of high-quality agricultural land in the planning system, so best and most versatile, or BMVs is called, and also the agricultural land classification system. This part of the work, we've been involved in a number of large-scale solar farms recently, so we've got quite a bit of experience with renewable energy on that point there. We also have a role in restoration and aftercare of quarries and mineral sites that are going back to an agricultural after-use. Historically, this was all about open cast coal sites back in the day, but we're now evolved more on sand and gravel sites, limestone, hard rock, and recently we've been more involved with wind farm developments using borrow pits for tracks and construction compounds, that kind of thing as well. And thirdly, and most importantly, we have a peatland policy role. This has got two parts to it really. Firstly, we're the sponsor of the National Peatland Action Programme, which is delivered by my colleagues in Natural Resources Wales. And I believe Manon Roswen and the team are up there at the conference today, so you can catch them to get a bit more information about that programme. And secondly, most relevant to today, we also represent the peatland policy position in planning, application and developments. This is largely involving wind farm developments, going through what we call developments of national significance procedure in Wales. So that is any energy project between 10 megawatts and 350 megawatts is decided by Welsh ministers, not local planning authorities. Just to give you a quick overview of the peatland resource in Wales, we've got just over 82,000 hectares, which is just about under 4% of the terrestrial land area. It's probably remnant to sort of more extensive peatland resource we once had years ago, but over centuries of adverse land use, this has sort of declined, and probably the extensive areas of shallow peats and organomineral soils we have has been derived from deeper peat soils. But in the past, of the peat resource, about 2/3 is supported by semi-natural habitat, and of that, about 10% is considered to be in good ecological condition. The map on the screen there is from our Peatlands of Wales mapping series, which is publicly available and freely available on NRW's Peatlands data portal and also on Data Map Wales. So it gives you the extent of the resource in Wales as well. So it's quite concentrated in certain areas. As to definitions in Wales, as a policy, we tend to use the Soil Survey England Wales definition of peat. So that is, over 40 centimetres within the upper 80 or over 30 centimetres directly on bedrock. We also, and importantly, consider the shallow peaty soils as well, especially if they support peatland habitat or are integral to the wider peat body and hydrology. And that can be on-site or adjoining. So we don't sort of cookie cut the centre out. We have to consider it in the whole peat body and the whole resource, really. In terms of planning policy in Wales, right at the top of the tree, we have what's called Future Wales, which is our national development framework. And this has two key policies to support renewable energy. That's policy 17, which supports, a wide range of renewable energy and low carbon energies. But also importantly, it's not at the expense of the environment. So all proposals have to demonstrate that it will not have an adverse environmental impact. Policy 18 goes a bit further, noting, designated sites and protected habitats and species, that kind of thing as well. But it also notes, and importantly, that, there must be what is called acceptable provisions for decommissioning and effective site restoration in applications as well. That's a key point that we look for in applications coming forward as well. Underpinning all this is policy 9, and you can see the image there, the map of Wales, which is all about resilient ecological networks and maintaining those as well. And on the map, it highlights things like carbon, upland habitats, natural flood management, which are all underpinned by peatlands as well. Going one step down, it's Planning Policy Wales, which sort of does what it says on the tin, really. This is our the policies that we tend to look at for development as well. This was updated back in February this year. However, about a year ago, the then Minister for Climate Change published with immediate effect amendments to emphasise the protection of peatlands in PPW. This was mainly in response to the Global Biodiversity Framework agreed at COP15, the Biodiversity Deep Dive the Welsh Government took back about 18 months ago, and also to sort of fulfil our Section 6 duty under the Environment Act, which aims to maintain and enhance biodiversity and the resilience of ecosystems in Wales. So firstly, the stepwise approach was strengthened in respect to peat with a very clear emphasis now on avoidance. Step 1A, as you can see, I've highlighted a few areas there. So it's focusing very much on site selection stage. So, should you be developing these sites if it's got to be impact on peat? If so, can you avoid the peat impacts there? Section 1B of stepwise now is extended because it was previously only covering designated sites, but now it covers what's called irreplaceable habitats. And also, if you can see the footnotes below there, it gives you a bit of a definition or an examples of what they include here. Importantly, it covers the natural resources which underpin them. So that could be hydrology, peat soils, that kind of thing as well. And listed there are things like peatland, blanket bog, and lowland fen. And the policy is quite clear, and it notes it quite clearly there that development on these type of habitats would only be justifiable in what's called wholly exceptional circumstances. So there's quite a high bar in there as well. Planning Policy Wales does go a bit further in respect of peat soils with paragraph 6434 there. This is a new paragraph, and again notes that when I quote it, a considerable weight should be given to peatland protection in policy as well. So looking at linear developments, here's a few thoughts and observations that from our experience over recent years dealing with wind farm applications mainly. It's quite welcome that there's a focus today on linear developments. With wind farms, historically, the focus was only on the turbines on peat. However, there's a significant amount of infrastructure involved with these developments. Not just turbines, but it's crane pads, it's tracks, it's drainage ditches, it's cabling, it's the cabling and cement-bound sand, the borrow pits for stone for tracks as well, compounds, all sites, all kinds of infrastructure involved as well. So it's very key that we know what the impact of all the infrastructure is on the peat resource at a very early point to consider in the application. From our experience of recent cases, we've seen very little evidence of avoidance of peat, both in site selection and infrastructure placement. Developers do tend to go straight for mitigation and compensation, not avoidance, which is not ideal. And we are starting to see improvements of this now. It's starting to move, and it's probably in response to the changes to PPW recently as well. Sustainable reuse, excavated peat can be substantial in some of these cases from all the infrastructure involved. It's not just impacts on the in-situ peat or the surrounding peat body, but what reuse is going to be made of that peat, and can it be sustainable and can it maintain function? You know, we've seen peat used for things like track dressings and verges, that kind of thing as well. But on one site we visited recently, the entire peat resource had either oxidised or eroded away within less than 4 years. So is that a sustainable reuse, or is that direct loss as well? We also see a lot of proposals for novel techniques for maintaining and keeping the peatlands functioning. But again, these have very little evidence to back them up. They probably are quite high risk. And also, what's plan B? What happens if it doesn't work? So those are things to be considered as well. Long-term impacts, again, we aren't seeing a lot of monitoring and evidence coming forward in proposals or applications to consider and address this in the development as well. There's a large gap there as well. So, you know, what is the impact on hydrology, on wider habitats, on the wider peat area? I think that's something that needs to be addressed urgently as well. Decommissioning, if you remember earlier on, I mentioned Future Wales, there is provision there for decommissioning effective restoration. In a lot of cases, this is pushed back to post-consent condition, and the proposal do put decommissioning steps forward. All note that tracks will be permanent and they won't be removed. So there's a question there: can they be removed? Will that cause more damage? There's going to be compaction issues. There's going to be no peat left to restore it in 40 years' time. There's going to be bare ground. Is there a no erosion risk? There was a lot of questions and risk involved there as well. Loss is loss, because we are concerned about the number of applications coming forward involving peatlands as well. I think all these losses add up together, so we have to consider them in the whole. But you know, how much loss is acceptable, and that's something we need to consider quite carefully as well. But you know, even if restoration is offered on site, that's expected in Planning Policy Wales now. There's avoidance plus enhancement, and you can't use that to mitigate or compensate for the loss on site either. Another one to consider as well is repowering. A lot of these applications are for 40 years. What happens then? We recently had an application that noted that if repowering was to go ahead, they would likely to need new infrastructure, especially turbine bases, but also upgrading of tracks, because turbines are getting bigger. More borrow pits to put more tracks in or extend or upgrade tracks as well. New cabling, that kind of thing as well. So is this ongoing loss of the peat resource in the future as well? So that needs to be taken into account. Just a few more examples we see coming through, and sort of that proposed to reduce impacts. First one is floating tracks. There's a bit of bugbear of mine. I think the terminology is very misleading. They don't float, they sink. And I think we should propose changing the name them to sort of overlaying tracks, really. We saw a site recently where basically stone was tipped in until it sank, probably up to 3 meters before it stopped. So there's significant damage to the peat stratigraphy there as well. There was also upslope hydrological impacts as well, drying downslope, loss of peat forming vegetation as well. So we need to consider that in the whole as well. Similar issues with rock displacement as well. There's lots of direct and indirect impacts. Are these permanent? Are they reversible? Is there evidence to support this as well? Do they do less damage in the end in the long term? And also, there's a distinct lack of monitoring and evidence to support these proposals and techniques as well. So I think that's sort of something to take in mind also. But considering the fragile nature of peatland habitats, all these types of track will have an impact. the question is what is an acceptable impact? And with planning cases such as these, it's down to us to make a representation for the peatland policy side, be the voice for peatlands. But again, at the end of the day, it's down to the planning inspectors and the minister to consider it in the round and make the determination. So what would help? Sort of a bit of a wish list. I think monitoring and evidence is key. From our perspective, there's a lot of tracks, as Mike mentioned earlier, on peats, not just on wind farms as well, and it's going back many years. So it's surprising that this information not coming through to support and to give us sort of a direction as to what is the impact. Is it good? Is it bad? What can be better? Kind of thing, really. As well as peat loss, hydrological impacts are key to understand, especially in response to the wider peat resource and shallow peatland habitats as well. So we need to look at this from long-term perspective. Also, mitigation methods proposed. Do they work? We're not sure. Is there evidence out there? And I think we'd welcome more sort of peer-reviewed on-site evidence to support that one, really. So just to briefly summarise, I think the policy in Wales is very clear at the moment. It's avoid if it's on peatlands. Should we consider all tracks as permanent features there? Because it's very unlikely that they will be decommissioned and removed. It'd be great to have more peer-reviewed monitoring, direct and indirect impacts, long-term on-site tried and tested methods, what we want to see really, and see if it works as well. Salami slicing, it all adds up. There's a lot of cases coming forward. I think a recent report by Renewables UK Cymru noted there's 33 wind farm applications in various stages in Wales coming through the planning system at the moment, and I think about 30 of them involve peatlands. So, considering that's on less than 4% of Wales, we need to consider, is site selection, is peatlands being considered at a considerable weight in decisions and in proposals coming forward as well. And lastly, I'll say it again, floating tracks, they don't float. So thank you very much. I'll leave it there for you.
Thank you. In essence, the questions are all about how careful we need to be, but these are the specific questions that IUCN would like us to address. At the top we have, what are the major drivers behind development? And do we have adequate science to effectively regulate developments on peat? Then we move into, is a mandatory period of baseline data collection and further monitoring required? That's more going into regulation. Can tracks play a positive role? It's worth, we do need them. If we're going to do stuff, we need tracks. We're not going to get there by flying in. Well, I guess we could with helicopters, but it's not really a practical solution. And then we move into more guidance and policy. So what I was thinking is we could maybe focus on the first 4 of these questions to start with, and anything you'd like to ask the panel, and then move more into the policy questions. Do you think that would be okay for the benefits of the IUCN?
If Jess could, I'm tech desk. If you could direct it to Jess.
Absolutely fine.
Okay. So, do we have any thoughts on the first 4 of those questions, or any specific things you'd like clarification on from the panel? So, do we have enough evidence? Yeah.
I'm just curious about, in your own presentation, you showed that graph with the machines and ground pressure, and machines with about 3 psi had significantly more ground pressure impact.
Oh yeah.
Than 1.5 psi. So, sorry, this is maybe off tangent slightly, but I mean, in our restoration, we ask for machines with less than 3 psi, so they usually come in around 3 psi. Should we be asking for less?
Yes, you should. There you go. Yeah. John.
John Walker, Swansea University. I recently, early this year, completed an evidence review of the impacts of wind farm development, operation and decommissioning on peatlands. Within the scope and the resources available, it had to focus on peer-reviewed evidence. There was not insufficient resource to kind of contact wind farm developing organisations. But in all honesty, it was shocking how little actually peer-reviewed evidence is out there on the impact of wind farm developments and on road and on tracks and roads on peatlands. And I had to cast that net very far
Yeah.
to kind of collate evidence about the impacts. Of
Yeah, I find it quite interesting that we say we want peer-reviewed evidence. We're not very specific as to what that would be. Andy works in the engineering sector. He works on the best available evidence, whatever that may be, rules of thumbs or whatever. You know, what do you think about, you know, what do we need in the way of peer-reviewed evidence? Just saying, do something isn't as helpful as saying, do this.
Right, well, all large schemes, most schemes have an EIA. An EIA is supported typically by MVC community data, which is collected before the wind farm is built. It's not difficult to go back to a wind farm which has a nice set of tracks to walk along and see whether those communities have changed prior to construction and now, particularly for long durations, and if there is change, how far that change has occurred away from tracks. It'd be very easy to quantify. There are stacks of PhDs in looking at impacts, which could easily be done, and they could use data now without having to monitor outside a PhD or even postdoc period. So we could just do that from the off. And we could also look at, is there disruption to hydrology? You name it, you know, how much of floating track subsided. Most of these schemes have floating track layouts shown in them. So go to the floating track sections, how much have they sunk? They won't all have sunk, some of them will have sunk. You know, how effective have the water crossings been? How effective have the drains been? It's all there. And Scotland's fantastic. Scotland has the Energy Consents Unit portal, which has all the Section 36 EIA on it for free to look at, with all the peat depth data. It's completely freely available since that portal was up. There's well over 10 years of very high quality survey data to use to support that analysis. And it needn't be done by the industry. It could be done by anybody. So I'd start there, personally.
Yeah, I was wondering what Arwel was thinking there when he referred to what does Arwel want in the way of peer review work, additional scientific evidence?
Yeah, thanks. You know, I think I'm with John Walker on this one. You know, it's not out there, it's not coming through in applications. That's what we're seeing as well. If it is, I think it needs to be in a much more accessible format. Because you've got to consider with planning applications coming forward, planning inspector needs to understand that he's not the specialist in peatlands and habitats. So it needs to be very, very easy to be interpreted as well. So I think that's a good point. But also, it's you know, the monitoring evidence as well. Is it there? You know, you're not sure if this is robust enough to quantify any impacts on it. So yeah, that's one to cover off as well.
Yep, Jess?
Yeah, I agree, John, because when I wrote that evidence review that Mike referred to, so much of it was pulled from North America, and one of the key things I found is actually much lower rainfall as well, so they don't see the same erosion effects either. So that was quite an interesting thing for me, and it came up in one of my peer reviews for papers, and when I looked at it, I was like, that's significantly less. So they're not seeing the same processes happening on those tracks, so we're then forced to extrapolate. And I think part of that's also in the funding of projects. And you talk about PhDs and how many could be done, but everything's now coming to global relevance, and so it's got to be looked at on a global scale. And I think there's not enough research being done here, and it overlooks the global importance of our peatlands as well. And we need to make a better case for that, I think, in general, to sort of be able to have the track data that we need, and to help make decisions, to help, you know, you guys in industry make good decisions as well, but based here.
Who would fund that research? It's not going to be a hot topic for the UKRI, I'll tell you that now. It's not really going to get them overly excited. So if you were going to think of how that would actually come about, how would it be?
I'm sure I'll be thanked for this. I'd like to see the renewable energy industry, so that's Scottish Renewables, Renewables UK generally, ask developers to fund research to support their own schemes. I think that's the obvious thing to do. They have access to all the site data. They have all the pre-construction data. They're in the best place to support that. And we are asked, from my point of view, when I'm asked as an expert witness in an inquiry, what is the evidence to support certain things, I need an evidence base to draw on to be able to respond to that question satisfactorily. So I would like to see that done, working in the industry.
So do we have anyone in here from that side of things that is from that? Yes. What do you think about that suggestion?
My name's Glenn. I work for Scottish Power Renewables as an ecologist. We've been in partnership with Strathcollie for a very long time, monitoring peatlands and the restoration process and all that kind of stuff. And this has been done at Blacklaw for, I don't know, 10, 15 years, a long time before I started. But there was a lot of, we have a lot of data on the oxidation effects of, and the drainage effects of floating roads. So that's one line that we've been monitoring since it got put in.
You have
So
it. Is it peer reviewed? This is the criteria that
We
the
do not
panel are
have it.
requesting. It's
It seems to be that, but you're not going to get that. You're just going to get the data, and if that's the best that we've got, that's all you're going to get. You know, this is done not out of any requirement from planning or anything. We've paid for this. You know, the company is paying for this to make sure that we're doing it right. Coming on to the future, we've got quite a few repowers in the pipeline now. We've got 2 sites in Northern Ireland where we've committed to, in our habitat management plan, which is now conditioned, that we've got to restore about 200 metres worth of track back to the bog, the best part of the bog that it was, you know, it was unfortunately built in back in the 90s. And we've got a test site near Whiteley wind farm, which we own. It's like the Whiting Woods of Scottish peatlands, and there's like all sorts of experiments going on there, where we're going to dig up a bit of track and try and work out how we're going to actually do this on a bigger scale. So that's just about getting underway, but the industry is starting to look at this. Well, at least Scottish Power. I don't know about anybody else, but I'm sure they probably are.
Do we have anyone else in the room? Are we on line? No, Mike. Sorry.
Cheers. Yeah, I was just going to agree with Andy. I think this funding should come from the industries. And they stand to benefit from reducing uncertainty in these areas about development. So yeah, it would make sense if they funded it. And you know, it's also a model that's been used in other aspects of renewable development. You look at offshore wind, the great uncertainty also in the aspects of consenting in that, and where there's great risks. You know, money's gone into trying to reduce those consenting risks to make the consenting process quicker. And this is the same to me. I think this is the same process, and we should look to developers to fund that research.
So, but you know, we've just heard Scottish Power are saying we've funded the research, we have the data, the own internal data. I imagine other companies are not dissimilar. I don't know if anyone here can confirm or deny that.
I'd be amazed if SSE were.
So would I. But,
You said there are lots of HMPs, so habitat management plans, that are associated with wind farms, and I'd say nearly every wind farm scheme being submitted now will have a habitat management plan. That will be a condition of consent, and it will need to be implemented. Whether the condition states that the information needs to be published is another matter. The other thing to bear in mind, as I'm sure you all know from peatland restoration, is that peatland restoration takes a long time, and you can't expect an immediate result, and you may not even have an immediate impact. So I think there's a lot of concern that the early days of reporting in an HMP may show nothing beneficial as part of compensation, when we all know it could take 20, 30 years, which is why code lasts so long. So providing we hold developers to the same standards as are being held for everything else, with an acceptance that it's going to take time, then I think hopefully we'd see an ability to be more open with that information. But it's certainly a discussion that has to be had and pushed forward, I think.
right, I think we should probably move on to some of these follow-on questions. And I think I'd quite like to put together the ones in policy here. So we have one about mandatory periods of baseline monitoring. I'll probably park contracts to a positive role for now. And is guidance and best practice required for existing vehicle usage, etc.? And then finally we have what policy directions are required. It may be the baseline surveys, it may be other aspects of policy. So what do you think? Anyone in the audience got thoughts on policy? I'm always drawn to Peter at the back there, but he's observing, I can see.
Well, no, I'm finding this fascinating. Sorry. I was getting
Yeah.
Sorry, Peter Hutchinson from Nature Scott. I think this is a fascinating discussion. I wasn't expecting it, so well done to the IUCN team. I think in terms of the protection and mitigation, there is a lot of experience out there, and we're working with the Scottish Government at the moment to try and draw together that experience. So I don't think it's peer-reviewed research, but we are trying to draw together people's experience, so the protection. I was going to ask, though, about question 4. I think that's the really interesting one. You know, we need to put these tracks out there, whether they're for wind farms, whether it's for deer management, whether it's for woodland management. So can we actually design the tracks and do it in a positive way. We also need to put these tracks out or take vehicles across peatland to do the restoration. The question Pada mentioned, and both Pada and I have noted your answer there. So I'm just looking for the audience, here just to give some ideas. Can we use tracks in a positive way?
I was already thinking that. It just seems like Joel from the CMPA. I was just thinking it's kind of like a giant contour bund. You could really re-wet some serious areas if you wanted to with the use of tracks. I don't know how that would work in practice. I don't know if it would be risky, but certainly interesting.
Effectively, better track design, is that? Who else would like to? Anyone else out there thinking thoughts on better track design? Just throw your hands up if you're in the mood. Over there, they call. Drawing a bit more audience participation here rather than keep on going to the panel. Go for it.
Chris York from Walking the Talk. I've just done some work for Nature Scott, looking at paths, recreational paths, and where they cross peat. And I was really glad that you picked that up in the first place. And one of the issues we've got there is on a path that people walk on, 5% gradient, don't even think about it. I was surveying last week at 35%, a desire line going 35% up, deep peat. That's what we're dealing with at sort of path level. It's a completely different game, and I think we've been struggling, the Upland Path Advisory Group have been struggling to think about how do we manage paths that clearly have a lot of recreational interest across deep peat, 2-3 metre peat. I was working in Ireland last week on a peat bog with a very big desire line, 25 metre desire line across it. So some guidance would be really helpful there.
Would be helpful. Right, back to Andy. And then we'll go back to the back of the room.
Thank you. Yeah. Sorry, I'll be very brief. So yeah, we are considering using tracks as bunds, so that as part of habitat management, that's under consideration. The one thing I didn't manage to cover in my rapidly increasingly fast speech was there's quite a high level of constraint also from the turbine manufacturers who won't warranty track construction and hard standing constructions that deviate from a standard that they require, which means that your options to do something novel are difficult because it's difficult to negotiate a warranted turbine. That is a big battle, and we don't have a lot of control over that. Okay.
Could we pass the microphone to the back of the room? Just the back beside the door. Thank you.
Hi, sorry. Amber Bush from IKM. I suppose one of my questions about, or thoughts on tracks is, it's fine to an extent when you're talking about permanent tracks. If we're looking at temporary works and looking at GI, for example, I'm working on a site at the moment in Lewis. It'd be very difficult to be able to design tracks when you've got to have a coverage of GI for that extent, to be able to design tracks to be able to be beneficial in the way that you're discussing at the moment, I think. I think utilising the different types of machinery, looking types of machinery you're using and things like that is, and using either track matting or bog mats and things like that is a far more practical way of dealing with it. Going slightly off that, I think one of my questions, especially Nature Scott being in the room, is how, from a consultant's point of view, we are often in a position where people will say to you, is this a nice to have or is it a requirement? And I struggle sometimes with this type of thing where, in Scotland in particular, from a biodiversity point of view and alike, when it's, like we're talking about maintenance, when it's not a maintenance requirement, it's a legal requirement, it's very difficult to push the industries to do a lot of this work. You can do a lot of carrot, but sometimes there is a requirement for a little bit of stick to say, yes, that's very good, you can get these benefits from doing it, but it's also your statutory duty to do it. It's a statutory requirement. And that would be helpful from a consultant's point of view. It'd be very helpful to be able to have something as an environmental consultant to lean on slightly to say, you know, this is a statutory requirement.
In essence, what you're saying is that more guidance, more policy guidance would be useful from a consultant point of view. Any thoughts online about that? And Jess is going to say something. I just want to... Oh, you not? No? I don't know. They look a bit kind of glazed.
I think I was going to say about with the regards to whether temporary tracks could be useful. I think that mesh geogrid, it can be rolled out and it could be taken away, and it certainly alleviates some of the pressure, because one of the things that my presentation was obviously just quite a brief intro. One of the things that I kind of, there were a number of tracks at Moorhouse that I studied, and one of them is an unsurfaced track, and Dave Stone knows about this track. And the driving was suspended on it after just 24 passes because it was causing so much damage. But I took compaction measurements down that track about 7 years after it was abandoned, and it was 3 times more compacted than the controls, and that was just an ad hoc, Argo Cat unsurfaced track. If you put a mesh in at about the same passes, it does alleviate a lot of that pressure, but you can't leave the mesh in, because then when you take it out, everything just comes with it. And we tried mowing that sort of vegetation off to remove it, but I think there's a role for it as a kind of temporary solution, that mesh track. But it's that thing of when it's a permanent solution, the tensile strength of it's really poor, so you can't use it as a repeat passage thing. You see it breaking up. The RSPB have talked about that sort of thing as well to me in the past. So yeah, but I think there is a use for temporary tracks in restoration.
Yeah, please.
Peat impacts in not just site selection but in the design of an infrastructure as well. But we have seen a number of cases going through where they've done their best to avoid as much as they can, but there is a pinch point somewhere, whether it's a track crossing a peat bog and that's the only access into the site. So it's very difficult then for us, because from a policy perspective we probably will have to object to it because it is a peatland impact. But if the developer then can sort of demonstrate very, very clearly and logically why they have to go there and what they've done to sort of, minimise the impact as much as they can, then it's a matter then for the sort of determining authority to consider it in the round, and is it permissible or not, and will they accept it or not, really. So if they're using, novel techniques or track matting or whatever it may be, that might be an option for them to consider to help their case there.
At the bottom there's a question about the IUCN's role in this. We've still got a bit of time left. And the question is whether or not the IUCN should have a position statement on tracks and peat. Whether that would be helpful. In some ways it's not really policy, but it is influential. It would relate to restoration as much as it would do any particular track, because you have to take vehicles onto peat to do the restoration. What's the thought on that? Okay, we'll go.
Well, I guess because you asked an IUCN question, it probably makes sense that I answered it first. So I guess to reflect on our role, we already have a couple of briefings on developments on peat more generally, which touches on planning policy, but also on the evidence base around tracks on peatlands. And I know Jess is working on an update to that tracks on peatlands briefing to kind of bring in some of the latest science and evidence that's been presented here today. So that's kind of our current position, if you like. And I guess I would say in terms of a position statement, I think with tracks, it's a very much an it depends. We've heard today a lot about a suite of different variables depending on the reason for why that track's going in, the landscape it's sitting in, the topography, all the rest of it. So in terms of a firm position on tracks and peatlands, I guess it would be difficult for us to arrive at that. But I think what we can do is to make sure the evidence base is presented in an accessible way to policymakers, so that can feed through to some more informed decision making, because I think that's quite clear from what we've seen today, is that maybe in some cases some of the decision making hasn't been well informed.
I think I'll try and get over there and then back to industry for what may well be the last word. But I would really like the view of industry on policy.
Yeah, it's 2 hour slots. We've got
2 hours. That was it. 2 hours. That was half an hour. All right. Dear, I'm rushing through it for a 1/2 deadline. All right. We. I'm really sorry, folks. We could be here for another half hour at this rate. I thought I was making real progress. Yeah. Please, over to you.
Dave Stone from Joint Nature Conservation Committee. So just picking up where you left off, I think there is a role for IUCN, not only in setting out that evidence base, but I think what would be valuable is to set out some of that decision process, some of that thinking, so that the sorts of considerations that we've heard about today are actively in that thought process and are being done consistently. So it's not so much a position statement, it's a sort of good practice when you're thinking about tracks, and I think that could be valuable.
That's comfortable, yeah, in terms of a set of recommendations almost that need to be kind of thought through.
Thank you. What is not the last vote, but will be an important vote. Thoughts and policy and positioning, please.
Andy and I were discussing this earlier, and it's the distance that this knowledge from all of you guys in the room that are leading this research has to travel before it gets to the people digging the tracks. We've got tracks they are a bit of a necessary thing, problem we've got to have to deal with, and I've seen tracks on our wind farms where I've been like, why have they done this? Like the method is all laid out, there's a peat management plan, there's all of this stuff, it's come down from research, it just gets stopped. The site labourers don't read it, okay? So it's really important that, well, I don't know whether it's going to be IUCN's Peatland Programme that's going to be leading this, but there needs to be some direct training from people who are able to really clearly explain about compaction. It's all material science. It's simple for them to understand. Just go directly to the people that this is really interesting me. I don't really need to know it. It's not. I can monitor it and tell what's going on, but I'm not the one who's going to have the influence over the habitat in the long run. So I think that just closing that gap, that loop, and just going straight from research to.
I think that's a really important point.
Implementer is
back to the practitioner, the person driving the digger in the bog. Yeah, effectively.
That's it. I'm dreading what's the.
I've got a question. Question at the back. Yeah, comment at the back. Could you just pass that through there?
Yeah, thanks, folks. Very interesting discussion. My name's Stephen Fraser. I work for Forestry Land Scotland. I'm based up in Caithness and cover parts of Sutherland. My job is Forest Liaison Officer for Renewable and Infrastructure Developments. I've kind of been involved in monitoring the building of 5 wind farms, mostly on deep peat sites. I'd say in the kind of 12 years that I've been involved, not really much has changed in terms of what you get despite best habitat management plans, peat management plans. We have NPF4 that should protect peatlands in a better way, but we need to kind of work out how best together that we can form a strategy, a better policy at the beginning, get the developer more involved at the beginning, almost like micromanage where they want to develop anything on the site. The gentleman in Wales, I like his catchphrase, avoid, 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 but we have them, but it's how we go forward. A lot of the developments are maybe 10, 12 years in the making and have consent. I would say that as well as putting the onus back on the developer, we almost need to think how we don't get the digger driver doing something. I mean, let's face the realities of this. We've got thousands of tons of stone coming out of borrow pits with large construction equipment covering large meterages of development in a day. Quite often the monitoring that's done on these developments is by the developer with staff that's paid by the developer, so we need some independent monitoring on the sites to make sure that we have our peatlands not just for our generation but for the generations and the flora and fauna that depend on it.
Yeah. So you comment about the micromanagement there. in real fine detail of exactly what is happening. Is there a practical way of achieving that? I mean, how would you see that sort of happening?
I do think that if some of our regulatory authorities were perhaps financed better, we could maybe have the developer maybe wholly or partly fund independent bodies to have a long-term presence on the site and to be involved at the planning at the beginning.
Peter's got a thought there, I think.
Yeah. Oh gosh, that's good. I think I'm going to link the two questions. The question from the lady about standards. I think we do need to update our guidance so we're clear on what is good practice. And I don't know if anybody was in the workshop this morning on the Peatland standard, or actually it might be going on this afternoon. But we are trying to take the range of guidance to do with peat and how it affects development, how it affects restoration, and bring it all together so we've got it in a single place. So we've got clear guidance. The next stage, though, is we've got to get that knowledge out there, you know, and just sending guidance out isn't the answer. And that's why we need to do training at various levels. So the policy people know about it, but also the practitioners know. And it will be a different way of getting that guidance out for those different audiences.
So really an effective communication strategy.
Yeah, so it's not just having the knowledge, it's actually cascading it.
Okay. Well, and maybe if you could use the mic.
It would be guidance, and what we can do is we can link to it in any consenting. So, you know, the conditions of standards is in accordance with the agreed Peatland standard. So it's linking the guidance.
Yeah, maybe the microphone could travel via the gentleman over there by the pillar, and then we can come back to the front.
Just to sort of capitalise perhaps on what Peter was saying, the thing about training, it's as much about competency and ensuring that the operators on the ground have competency, and if there are standards that they have to meet, so that every operator has to be able to demonstrate that they can do what they're supposed to do on peatland, rather than just say, well, I'm a civil engineer and therefore it's fine, or I'm a digger operator and I've worked on a building site, so that's fine. So competencies, and I think, to be fair, the training that's available through the Peatland Action for machine operators develops that competency, and it's got to be a way of measuring that and giving people the ticket that says they can work on peatland.
And also working in partnership with them, because there are standards of health and safety. There's places you can't take heavy machinery. There's all sorts of problems when you're on steeper slopes. We need to be, cognizant of the difficulties of doing some of these jobs. Over to you, Andy.
Thank you. So firstly, regulatory bodies need to have the appropriate regulatory teeth to pause construction if the plans have not been delivered as submitted, pre-consent and conditioned. Secondly, we are starting to specify, you may all have heard of environmental clerk of works, we're starting to specify peat clerk of works specifically to manage purely the peat issues on site, so that the environmental clerk of works can do everything else, because there's a lot to do and construction happens quickly, as you pointed out. And what was the third point? Oh no, it was a good one as well. It'll come back to me, I'll pass it to somebody else.
Someone else back there. It's going round in a circle, isn't it? Thank you.
Joel. Just going back to that point, it's really interesting having because we find it in restoration as well, we want people that know how to work with peat on the hill. If that standard was demanded by wind farms, it'd probably impact our available workforce. And similarly related, the 1.1 tracks compared to the 1.9, 100% agree. But if we demanded that from every contractor, we'd also lose a huge number of businesses because it costs a lot of money to upgrade your machine and maintain your machine if on 1.9 tracks.
Absolutely. Yeah. So as we're having this conversation, that we may not like wind farms, we may have our own view on wind farms, but renewable energy is going to be at the heart of tackling the future greenhouse gas crisis, the global warming. Peatland is part of that. Oh, is there another person? Have I missed someone there? I'm not sure it was on.
Yeah, I think I was going to say, like, and touching on that kind of wind farm pointer being an important thing, I think I sort of touched on that very briefly in my presentation as the kind of what is necessary when it comes to tracks. And I think there is going to be some element that some of them will be necessary, but we've got to be really careful because, as I showed in that aerial image, if you put one in, they can act as arteries, so tracks come off all over, so we have to be prepared for that. And in some areas, maybe like wind farms, there can be greater controls put around those areas, but if you put one in an upland area, big remote area, little quad bike tracks appear all over the place. So I think it's a really important question, that necessity of them, and understanding that one may lead to many.
Yeah. But listening to people at this meeting, I have been struck by probably 3 or 4 times people have said to me, the Scottish Government have changed their view, wind is now the priority, peat is now in second place. Now, I don't know if that's true or false, but I've heard that said from others, not my own view. I've got no knowledge of that. But
Mike's just reflecting online around capacity of regulators there. Just that he doesn't think that we can rely on them to police implementation and check compliance with planning conditions.
Yeah. So I mean, Peter's shaking his head at that comment that I've. But
be everywhere, because our team is 2.8 full-time equivalents, so we cover huge areas, policy areas, and we've got a huge casework load coming in as well, so it's not getting any bigger. So resourcing is an issue, but also it'd be helpful with more resource. You could engage at an earlier opportunity and have more influence on minimising impacts and avoiding impacts if possible.
I was going to say Scottish Government have got multiple. I'm not.
I realise that.
But it's multiple priorities. We want renewable energy. We want peatlands to be safeguarded. We also want to
reduce deer numbers. We also want to increase our trees. The challenge is, we need to put our brains together to come up with the win-win solutions. So, Andy and I are working on some guidance that is trying to, achieve peatland protection and development. So it's working together. It's those win-win solutions that we're aiming for. So it's not a win-lose.
I think that's a very important comment to hear, given some of the commentary I've heard over the last few days. And then we're coming back. Thank God it's a small room, isn't this marvellous?
Yeah, the one mic.
Yeah.
So if I might chip on the regulator position, absolutely. There's too many schemes to have that level of staff, and we completely sympathise. Another one of the things that we're looking at is co-appointed peat clerk of works, where they're effectively an independent person who has the opportunity to cascade up and go, this isn't being followed, but equally works on behalf of the developer, because there is a worry that if it's whoever's building the wind farm and they're employing the clerk of works, that they will overlook things, and nobody wants that. I don't want that. And that is another route option, I think.
Yep. Oh, there's Olivia.
I'm liable to go wandering off. I'm wondering how to make a clear point here, because we looked at this kind of thing quite a while ago in terms of hearing win-win solutions. It was a question of how could wind farm tracks be constructed so that they had a minimal impact. Impact's a difficult word, but how they would cause least disruption to the functioning of the peat blanket. And that is to do with routing and the design of the actual track itself. I was hearing something over there, and about the sinking versus floating roads. The answer is it depends what kind of peat you're building on. Has it been drained before or not? But we were talking about this kind of thing as a win-win solution. You can have your tracks, but make them hydrologically fit the landscape, and then you could have a peatland actually in the wind farm. Instead of having to go somewhere else to compensate for what you destroyed, you might actually get the peatland growing up to the edges of the tracks if you thought about it. And the problems that came out was this is not required in legislation, so it's too expensive. and there are different standards for consolidation of peat if you're building something in a town from when you're building out there, because it doesn't matter so much if it goes wrong, if it all goes splurge, or if you have to pile in tons and tons of stone to do the consolidation. And there are standard techniques for when it matters that they put in piezometers and watch the overburden pressure disperse as they load in the stone. Yeah. So it's about managing the initial compression, and I would like to see that monitored by the installers. Yep. But they were totally, because they weren't required to do it, they didn't want to do it. And then there is the sediment issue. That's not been mentioned, that they put all this rubbish rock on top as the running surface on the road, and you get sediment off that. And really, you've got to contain that, otherwise that ends up all over the peatland. And just much better design and routing could go a long way towards sorting all of this out. And I think it actually starts with people with hearts and minds. You know, I actually want to have a wind farm. It's got to go across this peatland, but I don't want my track to have more impact than it absolutely needs to. And we do know enough about the way that peat functions to do better than is required by legislation at the moment. So where does that start? Right, with policy, but practice, monitoring, everything.
Yep.
Sorry, I don't know if that makes any point at all, but
I think
it's
it
a
did.
set of comments.
Yep. And it's a very useful set of comments. Do we have any more thoughts in the room on that topic? Have we covered everything here? Well, there's one here, but is there scope for greater strategic alignment between agencies, and that was agencies in the different nations across the UK? Are we all with one voice? England, Wales, Scotland, Northern Ireland? Anyone got a thought on that? I see one thought.
We might not be one voice, and I don't think. Sorry,
we're all working for different governments, so we might not be one voice. But I think we can be better at sharing experiences between us. And I was listening to Arwel's presentation, and I was thinking, I need to hear about his experiences. So I think we can be better at sharing. And can I just come back on the comment that the lady mentioned? I think that's really good. There is a hearts and minds here. And I've worked on renewables development and nature for many decades, but I am seeing now, the development community wanting to care for our peatland resource, so they are looking for the win-win solutions as well, and that's fantastic. So from my experience, are seeing that change in hearts and minds.
Arwel, would you like to comment on what Peter's just said, if you heard it?
Yeah, I think it's true. I think, sharing experience is very, very valuable across the board as well. I know we do different government, different policy mechanisms as well, but, there's a commonality between us all, I think, and we all look to protect the peat resource as well.
When you talk about
I think the policy position has been quite fast moving as well, especially over recent years, and it's probably just been in response to, a large influx of wind farm developments, just, to meet our net zero demands as well, so we're sort of playing catch up in a way as well. But hopefully, we'll come to a sort of position where we're all sort of agree on the way forward and can minimise the impact as much as we can.
How effective is the sharing of experience? I imagine someone from Nature Scot goes down to Wales and gets joined by someone from England, and they get together for a day and they have a wee chat about what's going on, and then they go back, and because life is busy and their work is very busy, they get on with what they were doing anyway. How much, and I get that. So what I've tended to find, academically or otherwise, is that you need a sustained effort at the communication over long periods of time, and by that I mean over periods probably in the order of 2, 3, 4, 5 years of reasonable communication channels assuming you're not meeting frequently, to really try to put something together. I mean, how is that viable within the structures you work?
I think it is. We do it in a way with our role on protecting high quality agricultural land and solar applications, because we do work quite closely with colleagues in DEFRA, colleagues in Natural England. Although the policy slightly differs, we do sort of keep in contact with each other and share experiences and share how different cases and sort of test ourselves on how we sort of view them, kind of thing, really. So I think it is possible, but I agree, it is a time commitment as well. But also I think it's really good to be simple and just get out on site and have a look, because we're trying now to get out on any new wind farm application that comes in, just to have a look at the site and get a feel of the site and get sort of an understanding as much as we can as of where the developer's going with it and why they're choosing different options and why they're doing things here and why they're doing things there. So I think that's quite valuable as well, just to understand from the developer's perspective, what they need and why they're doing it as well. But again, time is the issue.
How constructive is the dialogue with industry? I was talking to a person yesterday who was describing going to a hearing or listening to some planning case, and it sounded moderately confrontational, I guess, at the point they were discussing things and trying to engage in better policies and deciding whether policies have been appropriately applied, etc. I just wondered, when do you feel as if you have a constructive dialogue with the industry?
I think it's changing rapidly, to be honest with you, because we've seen, especially in recent months, a very different approach from applicants as well. There's a lot more consideration of peat impacts and how to avoid it as well, and also trying to engage with as soon as possible, even very early site selection stages as well. Advice, which is great. And the only issue is we haven't got the resource to support that for all the cases coming forward. So I think it is moving in the right direction. Hopefully, we can keep that momentum going.
Mm-hmm. Good. Yeah. At the back.
Stephen Fraser, Forestry Land Scotland. Yeah, I'm sorry, I don't really want to be a bit of doom and gloom, but it's not doom and gloom, because a gentleman here on my left from Nature Scott is right, is that there is definitely a move from developers to improve practices. But what we have to be careful of is that, and it has been touched on around the room already, is that is cascaded down to the likes of the principal contractor, who employs another civils contractor. So it's almost like Chinese whispers, and we can't have that. These good messages being watered down to the very sharp end, because as I say, that a lot of these peatlands are not getting the treatment that we deserve, and that's on a current basis. So.
You move over to
Yeah, I was just going to say on that, I totally agree. I mean, I generally am on the contractor side of things. But when things will change more if you can go down to a procurement where it's not led by cost, and it's led more by quality, but when the weighting is in the cost, then that is always going to be a problem. And there's no way around it. If your SSEs of the world are wanting to buy into it, they've got to change their procurement strategy.
That's a very valid point, I think. It's yeah. Any thoughts from
I'm
the
giving
panel?
it to you, Andy, sorry.
I think
Andy's got, raring to go there.
I just wanted to say, I'm surprised Peter's not said it. I was saying in Scotland, the dialogue's extremely good. There's the Peatland Expert Advisory Group, which specifically links industry, so that's contractor, developer, consultant, all regulatory bodies, charities, everybody. They're all together talking through these issues face to face around a table and on sites, warts and all, in an effort to try and make the guidance fit for purpose, which doesn't address the problem once it goes from consent to construction. But the up to consent part is moving very well in Scotland, and I would say that that's because of the effort of all those people involved. I completely take on board your point on quality on the other side, and I think Glenn's already made that point as well.
So it's back to that key question of how do you get that guidance through to the construction point? Is your yeah. No.
And just in terms of the contractor side, noting earlier about the training, there's a finite pool of restoration contractors, and sometimes restoration contractors aren't busy because there are not enough projects, but there are lots of wind farms moving, and I would like to see all wind farms in Peat have the construction contractor and a restoration contractor, and the restoration contractor should be moving the peat around because they know what they're doing, and the construction contractor should be building stuff, and that's how it should be partitioned, and that way that's going to get your best outcome. And that will also keep everybody at work, which is good. So you don't de-skill when you have a shortfall in funding, for example.
We have about 5 minutes left. I think we have covered a good bit of ground today, so thank you all for contributing. Is there anything else? Is there any other point that people in the room feel we should have discussed or is worthy of airing before we close the session? It's probably, as many people haven't said things, they may be dying to get in there for something that's not on the screen and hasn't been discussed, so I think it's a really good opportunity to get a view. Yeah.
So we've touched on it, and it's just that I don't. So Jess referred to the sort of unmade track stuff. So lots of this discussion has been about floating tracks, but actually the off-road stuff, the quad bikes, those sorts of things, and I think that's far harder to regulate, far harder to control, but equally impactful, and it's something that we're not going to solve today, but it's something that we need to keep in mind. And these floating tracks, they act like the sort of almost like an aorta for lots of unmade tracks to spin off as well. So it's just so that we don't lose that point, really.
Are animal tracks a problem? You see them from space. You can look at a picture of the flow country and you'll see lines crisscrossing it that the deer tend to follow perpetually. So when we have high deer density, does that create a track issue? The average large deer probably weighs several hundred kilograms. Its hooves are probably smaller than my feet. Therefore, if we do the pressure calculation, it doesn't sound too good. Yes.
Pather from Peatland Action. Yeah, I mean, and deer tracks can become, erosion features quite easily as well. But also in very popular areas where you've got upland bogs, for example, but you've got very popular Munro or something, and you've got a huge amount of erosion there. And I do wonder what's the best way of tackling that, because maybe putting in a hard track would create less damage in that instance, rather than people constantly moving further and further away from that central muddy patch.
If you look at the amazing changes they've made up the Altavulin, going up Ben Nevis, where you had that used to be a sprawling morass of wet peat, and now it's really quite constrained, and a lot of it's improving either side of the path. It's always the come on, right, back to you.
Interestingly, you ask about the hard tracks, because Mark Owen from Natural England, who was in our Peat Depth session this morning but isn't in this one, unfortunately, but I said to him about that, if you put a hard track in, would that actually maybe solve the problem of some of these? And he said he felt that was naive, that it would we would still end up with people wandering off. I suppose that's one of the problems of open access as well. There is that right to roam, but maybe it's considering where we're roaming and trying to lighten the pressure rather than always following the same trods. But it comes down to that issue, as I mentioned, of bogs are hard to walk over, so a trod is a reprieve, unfortunately. But it's a very difficult question to answer.
But you have avenues for that, like Mountaineering Scotland or BMC. On the right track could be a campaign for those organisations to raise awareness of not deviating from the track, doing your best not to destroy the landscape, understanding the equivalence between feet and heavy vehicles, I bet it's lost in many people, even though the evidence of it is clear. Yeah, sorry.
I was just going to pick up on that. Mountaineer and Ireland are already doing that in terms of providing guidance to people in terms of crossing bogs. So encouraging people to stick on the line rather than moving off. And the issue of people on bogs heading for Munros is a really difficult challenge, because people, in terms of their psychology, what they're doing is they're going for a straight line. You try and reroute them and they will really, really struggle. So we've got 3 or 4 examples where it has worked, but loads of examples where it hasn't worked, where you've tried to push them a few hundred metres off. And that's really, really difficult. As soon as you create an easier piece of ground, that works, but then it doesn't if it's a dry day and somebody's got some stones to walk over, they'll hop off them. So you do your best job at path work, and they'll hop straight off them if it's slightly uncomfortable. So
if you're knackered at the end of the day
on auto stumble,
and you come down to that choice of the deviation or straight across the bog, I know what I've done. Shame on me, but I have. And no doubt caused a lot of damage into the bargain. So. Okay, well that takes us to the end of this session. Thank you all for coming. Oh no, sorry, we've got one more at the back. I was about to. The last.
Thanks very much. Sorry to keep you from coffee and things, folks. Stephen Fraser, Forestry Land Scotland. It's kind of a message, a question for Andy. Andy, I do like your suggestion of a restoration contractor being on development sites. Do you see these potential peat restoration contractors being overseen by the developers? Do you think that they should be on an accredited list? And it's kind of linked into the first point, who should be paying them?
They should be paid as part of the construction costs, because they're delivering mitigation of impacts, so that's clear. Accreditation would be helpful because it would ensure that only candidates who do everything correctly and have a certain level of experience are able to deliver, because these are big, potentially environmentally damaging schemes that need to be delivered properly, so I think that would help. And sorry, I've worked backwards through the question.
Was it interface, I think, between the...
so this is where a peat clerk of works would come in, which is essentially to say we've got a load of peat being dug up there, restoration contractor go there and deal with it, and I'm going to oversee it while the environmental clerk of works does something else. But there's a skills base there now that there probably wasn't 10 years ago, so there's more resource to draw from. Whereas I think we were quite resource constrained a few years ago, so that should be more possible. But yeah, certainly should be paid for as part of construction. It's part of construction in that context.
Okay, thank you.
Okay. And with that, I think we will close the session. So thank you all.
Yeah, thanks, David.